So for this video, I'll be covering problem 3 on discussion worksheet 19. It says complete the Lewis structure of the compound shown below and indicate which of the following statements are true. So first we got to complete the Lewis structure. We got to make sure all the atoms are satisfying the octet rule. So now that we've done that, we can indicate which of the following statements are true. So first, the pi bond between carbon 3 and oxygen is formed by the overlap of unhybridized p atomic orbitals. So it's important to remember that a double bond always consists of one sigma bond. In this case, it's formed by the overlap of sp2 orbitals, where the electron pair is located directly between the atoms, and also consists of one pi bond, where the shared pair occupies the space above and below the sigma bond, and that is formed by the unhybridized p atomic orbitals. So that is why it's true. Next, the carbon-nitrogen bond is formed from the overlap of sp3 hybrid orbital from the carbon atom with an sp2 hybrid orbital from the nitrogen atom. So this is false, because the carbon-nitrogen bond is formed from the overlap of sp2 hybrid orbitals. The key indicator here is the double bond. If you see a double bond, that is formed from by the overlap of p orbitals. By both carbon and nitrogen have 3 sp2 orbitals and 1 unhybridized p orbital. The p orbitals are participating in forming that double bond. So it's overlap of sp2 and sp2 orbitals. So next is there are 3 lone pairs of electrons in the complete Lewis structure. So if we count the lone pairs we added, there are 5 lone pairs of electrons in the complete Lewis structure. So that's false. Next, there are 4 pi bonds in this molecule. Well, we only have 2 double bonds. So, and that's a key indicator of pi bonds. So there are only 2 pi bonds in this molecule. So that's false. Next, there are 11 sigma bonds in this molecule. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 sigma bonds in this molecule. So that's false. Like I said, it's important to remember that a double bond consists of 1 sigma bond and 1 pi bond. Next is sp2 hybrid orbital on carbon 1 overlaps with sp3 hybrid orbital on carbon 2 to form a sigma bond between carbon 1 and carbon 2. That is true. Wait, what's going on? Oh. Okay. Sorry about that. So that is true. The sp2 hybrid orbital on carbon 1 overlaps with sp3 hybrid orbital on carbon 2, forming the sigma bond. And last, the carbon 2 and carbon 3 atoms cannot rotate about the internuclear axis between the 2 atoms, since the sigma bond would break. That is false, because the sigma bonds can rotate. It is the double bonds that cannot rotate. Pi bonds are weaker than sigma bonds due to the side-to-side overlap being less efficient than the end-to-end orbital overlap. Pi bonds in a double bond are generally easier to break than a sigma bond. So that is why it's false.